limit comparison test for positive series. Let's suppose that the limit of an over bn equal a real number L and positive real number. Then we have two cases. If sigma an converges, then sigma bn also converges. So they converges together, or they diverge together. Okay. So if the division an over bn positive, or the limit of the division bn over an positive, so both of them will be either diverge or converge. Let's take examples. In the first example here, we have this series sigma an from n equal 1 to infinity. So let's take bn as 2n over n power 3. So it's 2 over n power 2. Now let's take the limit of an over bn when n goes to infinity. So it will be the limit of an, it's 2n plus 1 over n power 3 plus 5 over 2 over n power 2 when n goes to infinity. So it's equal to the limit. Let's take n power 2 up. So it's 2n power 3 plus n power 2 over 2n power 3 plus 10 when n goes to infinity. So the answer will be 2 over 2. It's 1. If we divide by n power 3, let's divide by n power 3. So it's the limit of 2 plus 1 over n divided by 2 plus 10 over n power 3 when n goes to infinity. So this limit is 2 plus 0 over 2 plus 0. So the answer is 1. Okay, so always because of my definition of bn here, the limit of an over bn must be 1. It's logic. So because the number 1 is bigger than 0, now using my theorem, an and sigma bn will be the same. But I know that sigma bn, which is sigma 2 over n power 2 from 1 to infinity, converges using by integral test. Integral test. Because remember the rule. What was the rule? Sigma 1 over n power b converges if, I suppose, b greater than 1. So this was the rule of integral from integral test. Okay. So because the series sigma bn, now sigma bn is less than infinity, and because the limit of an over bn, it's 1 positive, now using the limit comparison test, sigma an from 1 to infinity converges. In the next exercise, we'll suppose an root n plus 1 over n plus 3. And let's define Bn as root n over n, root n over n. So it's 1 over root n. After that, what is the limit of an over bn when n goes to infinity? Because of the definition of bn as root n over n, so the limit will be 1. And this is bigger than 0. So I can use the test, limit comparison test. Now let's go back to my series sigma bn. Sigma bn, it's sigma 1 over root n power a half from 1 to infinity, from 1 to infinity. This is divergence. Or you can write equal infinity. Why? Because sigma 1 over n power p from 1 to infinity, the answer will be infinity f p less or equal 1. This is integral test. This is the rule of integral test. So my series sigma bn diverges. So, and because the limit of an over bn positive, now by limit comparison test, we will have sigma an, which is root n plus 1 over n plus 3 from n equal 1 to infinity diverges. So always if we have any exercise where we have polynomial down and polynomial up, we can always use this idea. So we can write this rule. If we have a series like this, up polynomial, down polynomial, or maybe also we can take something more general than polynomial. If k is instead of 1, 2, 3, would be a fraction, maybe k 5 over 2 or something like this, or half. So this series converges f sigma ak n power k over br n power r converges. Why? Because if I suppose this term here, an, and if I define bn as ak, this term n power k over this br n power r. Okay, this b different from this b. Okay, if I define like this, so what is the limit of the division of these two terms? So I will have the limit of an over bn will be 1 when n goes to infinity. Now, using limit comparison test, if this series sigma bn converges, then sigma an converges. And also if sigma bn diverges, sigma an diverges. Okay, now what about this series sigma bn? Sigma ak over br times n over power k. Let's write 1 over n power r minus k from 1 to infinity. So these akbr are not related to n, are independent to n. So we can take them outside the sigma. We can write after that sigma 1 over n power r minus k from n equal 1 to infinity. Okay, now this converges f r minus k bigger than 1. Why? By integral test. Integral test. Okay, so finally, if I have an exercise, like let's go back to the previous exercise, for example. So here, if I take down 1 up a half, the power, n power 1, n power a half, if I take 1 minus a half, the answer is a half. So it's not bigger than 1. So this is divergence. So directly I can decide that it's divergent. So the rule that I will take the power r minus k, if the answer bigger than 1 diverges. If r minus k less than 1, so this sigma an here, this term, all of this term, will be divergence. If it's less bigger than 1, converges. So if we go back to this exercise here, power 1 minus power a half, 1 minus a half, it's a half less than 1, so divergence. The previous exercise, I take here 3, n power 3, n power 1, 3 minus 1, 2, 2 bigger than 1, so converges. Okay, okay, like this we can decide, we can answer any question in this form.